Aha, it's recording.
Is it? Okay,
It
cool.
is. Amazing. Thank you.
Cool. So if there aren't any questions, then now we can go ahead and talk about a LeetCode easy problem. And this is a problem where I looked at it and I'm like, okay, what do I think, like what runtime can I solve this in? So take a few seconds and read through the description of the problem and take a peek at the examples, and then we'll talk about it together. Cool. Hopefully everyone's gotten a chance to read that. And so I guess the general gist of this problem is input, we're given an array of numbers, and we're trying to find the indices of two numbers that they add up to this target integer that we're given, right? So does anyone want to kind of provide some thoughts on like their initial thought of how to do this in possibly a brute force methodology?
Well, brute force way is to basically um, take each number in the array and add it to the next number, next entry in the array, and to see if they add up to the target.
Right,
And if it
exactly.
does match it, then return that number's index and the corresponding number's index, which is going to
Right,
be O. But this operation is O of n squared.
exactly. So if that made sense to y'all, so we have, say we're trying to reach 9 or something else, that way we don't solve it on the first pass, is that I'm going to compare 2 to 7 and then 2 to 11 and 2 to 15. Maybe I haven't found it yet. And then I'll compare 7 with 11, 7 with 15, and then 11 with 15. And that would be an n squared way of doing this. And why is it n squared doing it this way? Is because we're comparing the entire input set with from the perspective of every element in the input. So I'm comparing n different things n times, and that would make it n squared. So, okay, we've thought about the problem, like, okay, n squared, that would work. And I'm not gonna write code right now because I don't want to, but that's okay. That's a good way that we could talk about doing this. Now, does anyone have any ideas of how we could make this more optimal? And someone who's not Sohib, if Sohib was the one speaking earlier.
One person in the chat said hash table. That was Sarah. And then Colby said sort the array.
Cool. Okay, good thoughts. So a hash map would help us with our runtime because, like, how could we do that? Someone want to speak up?
As you can probably tell, I'm back. Yep. Seems like everybody's in the rooms.
So, hey, if you could mute, I think we can actually hear the other meeting through your audio. Thanks. Sarah, do you want to give a shot at explaining hash table? If you want.
Okay, I'm not like really experienced too, but this one's just like you pass through it once and you put everything into a map and then you pass through it again, then just see if the numbers match up.
Right, that's a really great idea. And what would be the time complexity of that general idea that you're giving?
O of n, right?
Right, because you're only passing through it. We pass through it once and then we pass through it twice, but that's okay. You'll learn in algorithms that O of 2n is actually equivalent to O of n. All of our leading coefficients don't matter. So as long as we're not doing O of n times n, then it's good. So that's a great point, Sarah. And using hash maps is constant lookup time, which means that it only takes O of 1 to look something up in a hash map. And that's a really useful tool to have in your tool belt when you're looking to solve problems. So that's an awesome segue into, this is a solution that I came up with that I thought, cool, this is definitely more optimal than the n squared solution. So we can kind of take a look at this, and it's just like Sarah said. We have our map, and then we only have one for loop where we iterate through everything in the input numbers. So right off the bat, it's going to be O of n, because we are iterating through everything in that numbers input. And kind of the logic behind, if you were wondering how we would actually figure out like if the number would add up to the solution or the target when we grab it from the map, is we check if the map contains the value that we're looking for by subtracting the number at the number's index I from the target. So say our target is like 9, and we have numbers at index I is 4. We're going to see if map contains 5. And if it does, then we can set our two result values to the index at I, which is where we got 4, and then we're also going to get the index from the map where we got 5. And we're getting the index because we chose to put in our map the index of that number in the number itself. So that is a really great way to take a look at this problem. And it is a great like representation of first solving a problem, O of n squared. But probably not the fastest solution. Great, now we can do it, and we refactored, and now it's O of n. Cool, everyone feel good about that? Hopefully happy times. Great.
I just want to clarify on the previous slide that why are we, so basically what's the purpose of subtracting the target from each of the entries on the numbers array?
It's to check if the map contains the value that we're looking for, because we want two numbers that add up together.
Mm-hmm.
And by doing this for loop, we're putting all of the values in there. So if it isn't found this first time, we're going to put it in the map.
Okay.
So alternatively, to make it a little more like less convoluted, you could have another for loop up here, kind of independent of itself, and put all of the numbers that are in the numbers array into the map. That way they're already there, is probably how I would do it. And then from there, you would parse through the numbers array one more time and check to see if they are in, like if target minus this number is present in the map, and then that would be your solution.
Okay.
Cool beans. Any other questions? Dope. Okay, so I chose to do another like easy problem, which I also wanted to like state that in my opinion, a lot of the like rankings of the LeetCode problems, whether it's easy, medium, or hard, are kind of trivial or like not relevant because some easy problems I have trouble solving, some hard problems I think are simple, and a lot of hard problems I can never solve. So, and that goes for mediums as well. It's like people who I know who have been software engineers for 10 years can't solve some of the easies. So don't get too hung up on the categorization of them. A lot of the like secrets behind solving LeetCode problems is just recognizing the algorithm that you need to use. So don't get like spooked by, oh my God, I can only do easies. Honestly, same. So Cool. Did someone raise their hand? Jen?
Yeah, this isn't related to the specific question, but I was just wondering if there's like a specific language that we should be practicing on for LeetCode or whatever that companies use the most, or what do you think would be best?
Yeah, that's a great question. When I was recruiting in the fall of my sophomore year, I recruited in C++ because that's all I knew from 312. But that made my life really, really difficult, to be honest, because C++ doesn't have a ton of internal libraries and isn't super flexible when it comes to dynamically like sizing arrays or making objects is sometimes difficult. So I personally recruit in Java. Oh, and let me preface all of this by saying that whenever you do like LeetCode problems for a company or you're solving on a whiteboard, they let you choose whatever language. Or they will request that you do it in the language that you have listed first on your resume. So that's also another note. When you list the programming languages that you know on your resume, they should go from most comfortable to least comfortable. So on like my resume, I have Java and Go, C, C++, Python, and then like other stuff. So I would recommend recruiting in Java or Python is what I would recommend, because I think that those are, again, the most dynamic and will allow you to kind of skip some steps that you would have to manually write out if you're using a lower level language like C++. But that does require that you teach yourself a bit. If you're an underclassman, you haven't taken the classes where that's necessarily taught yet. So yeah, but I use Java because I'm most comfortable with it, and I find that a lot of interviewers know it too.
Oh, I didn't know you could choose. Thank you.
Yeah, no problem. Any other questions?
Question in the chat. Any suggestions for learning Java?
Yeah, there's the MIT OpenCourseWare website where it's just like free MIT classes. I taught myself a lot of Java before I learned it in WE422C, which is software design 2. That's where I learned a lot of Java. And I also just watched a ton of YouTube videos, and that's a lot of how I've learned Python on my own, is watching YouTube videos. And honestly, I like reading textbooks. I'm probably an odd man out for that. So, but I do read textbooks to help me like learn languages, but I find that helpful.
And then similar question, any advice for learning algorithm?
Yeah, tons and tons of great resources on YouTube for learning algorithms. I don't have any specific channels that I watch. I just kind of Google like introduction to algorithms video, and the book Cracking the Coding Interview is like a staple among software engineers. It's like the Bible to them, or to us, I guess. And so that is really, really key to becoming familiar with the algorithms you should know for interviewing. And then take W360C, which is algorithms, as soon as you feel comfortable with it and qualify for it. Like you have the prereqs, because that class is key. It really is, and you learn a ton. So I would recommend doing that. But yeah, YouTube videos, key. Mostly YouTube videos with algo, because I'm a visual person also. So seeing them like draw out this stuff that you would normally see in like a classroom is super dope. So.
To make optimal algorithms, what data structures do you usually rely on, like hash tables, and like what other data structures do you typically use?
Right. That is a tricky question, because I want to say it depends on every problem, but I do rely heavily on maps. So hash maps, and also relying heavily on array lists if you're using Java, because that can help you look things up quickly if like with certain types of problems. And I think trees are really, really helpful because searching through, whether it's a binary search tree or else, those are usually log n to traverse through. So if you need to make a tree and search through it, that would be an n log n algorithm, which, yeah, would be better than n squared. So probably maps, hash sets, trees. Yeah, those are probably the most important ones I've used.
Okay.
Sorry, if, I just had a question about like, do you have are there any questions about concepts such as dynamic programming or like the network flow, the deeper programming concepts?
Yeah. Things such as dynamic programming, recursive solutions, yeah, all of those do come up. And I didn't know how to do those until I took algorithms, which I probably should have been more thorough teaching myself. I'm not going to go over what dynamic programming is today because there's no way I could do that justice. But that might be something that y'all want to write down, is dynamic programming. That's a way of solving problems when you're looking for the shortest something or the minimal something, or again, the max something. Those are kind of some keywords where you're like, oh, I might want to be using dynamic programming for this one. And that's what things like cracking the coding interview will teach you, is that there are keywords in these problem statements that they give you where you're like, oh, that's the data structure I should use. Or, dang, I think this is a sorting problem. Or I think I need to put this into a map. There's some kind of nuances that you start to get after a lot of experience in doing LeetCode and or doing some reading. So I wish there was like a list of that somewhere, but it's kind of by each person a bit. Cool. So I think next we can go ahead and talk through this next problem, which is another easy one, but honestly, in my opinion, it's kind of like a medium. I was like, oh, this is kind of hard, but we'll talk through it. So take a sec, read through it, take a peek at the example, and then we'll chat. Okay, cool. Hopefully that was enough time. So interesting. So we have two arrays for our input. All the elements of the second array are distinct, and the elements in array 2 are also in array 1. Cool. So how about I talk through how I would act in an interview about how I would approach solving this problem. Okay? So I would honestly do this. First step, reiterate the problem. You want to like say the problem back to them to make sure you understand it. Because if I read this back and I was like, oh, there's repeat elements in array 2 and all of the elements in array 2 are in array 1. And they'd be like, whoa, wait. And they would help me explain the, like, understand the problem. And that saves so many headaches. Because if you dig yourself into a hole and you're just like, oh my God, let me like write some shit down. Sorry. Then it's like, you're just stuck. So first, articulate what you think you're trying to do. Like, okay, dope. I think I have two arrays and I'm trying to sort them, array 1 relative to the ordinate in array 2. Interesting. So my first thought is maybe an n squared solution would be a brute force idea. And what I would do is, iterate through maybe array 2 would be my outside for loop. And first I encounter a 2. Then I'm going to iterate through all of the numbers in array 1 to see if I can find all the 2s. And then I'll put that many 2s at the beginning. Okay, and we'll do that for all of them. So after we do that for 2, then we move on to 1, the index 1 in array 2. All right, now I'm going to parse through array 1 and find all the 1s. So as I'm kind of talking about that, I'm realizing that this is going to be a nested for loop, and that means it's going to be an n-squared solution because I'm iterating through array 2 would be my outside for loop, and then my array 1 would be my inner for loop. And I think I can do this a faster way because that doesn't seem very optimal. And if I'm trying to count how many occurrences there are of something, because that matters when I'm trying to put it back in array 1, if I want to figure out how many occurrences of the number 2 there are, then maybe I want to use something like a map, because then I can figure out how many occurrences there are of this. But a map needs both a key and a value. And that could work, doing a key and a value. Maybe my key would be the number, and the value would be the number of occurrences in array 1 that there are. Okay. Or what if I did an array where the index is equivalent to the number in array 1, and then the number in that index is the number of occurrences? That might be better than a map, because we can see that there's constraints given down here. Oops. There's constraints given that it's going to be less than 1,000. So I only need 1,000 or 1,001 size array. And this problem doesn't tell me I have any space constraints. So, okay, I think this might work. So now I don't have to iterate it through and like do n-squared things. Now I can just iterate through array 1 once, and I encounter a 2. So I go to new array index 2 and increment that by 1. And then I do 3, go to index 3 and increment that space by 1, etc., etc. And now I know how many things occur, and then I can just iterate through that array once and line everything up. Or iterate through array 2 twice, or array 2 once, sorry, so many numbers, and then figure out the order and thus put them in the spot that they belong. That sounds like it'd be faster. So I think I'm going to pursue that, and now I'm going to start whiteboarding. I'm going to write out some pseudocode, which is mostly words, do a for loop here for array 1, going to do all this, write on the board, and then after that is maybe when I would write some more code inside of that pseudocode and trying to flesh it out. Cool. So this is ideally what I would end up writing on the board, is exactly what we just worked through. Is originally we had our n-squared solution, but like, I think I can do better. And better than n-squared would be traditionally n log n or n. So we were able to get it down to O of n. And we got there by creating this array, which was our counting array, and then iterating through array 1 once. And this line right here is how we are counting that index and incrementing it. And I think that's a pretty cool way of doing that without having to iterate through that array so many friggin' times, right? So what do y'all think about kind of that thought process of finding your initial solution and then trying to optimize it by thinking about some data structures that you know and figuring out maybe how can this problem apply to that? Super
Uh,
cool.
how was that O of n again? Like,
It's because I'm only iterating through array one time in this like first for loop here. And so I'm not iterating through that array the number of times that array 2 has numbers, if that makes sense. So I iterate through array 1 here, and yeah, I do have another for loop here and another for loop here, but that's just O of 3n, right?
which is
This is O of n.
O of n. I see. So you basically just you're just basically going through the for loop array 1 just to count the values, and then putting them in a counting array, and then just
To find the number of occurrences.
yes, and then you're just looping through array 2 to just basically populate to just get the output array to see if there are like more than one occurrences for a number. If there are, then
Yeah, to figure out like the sorting array, right? Because we want it in the order of all the 2s and all the 1s and all the 4s, etc. So that's why we loop through array 2 to figure that out. So honestly, that is exactly what I would do in an interview. As you get more experienced, you can jump to, you start to know, okay, I know a more optimal solution. I don't really have to think through this n² solution first. But I think that is a pretty good place to start, is doing brute force and then talking about, oh, actually, I think I can optimize this. And then maybe here, after I talk through my O of n solution, I want to talk about any edge cases I think there are.
Call anyways,
I'm like,
just to funnel anyone new into one of those.
I'm like, okay, are there any edge cases here? Like, what about if array 1 is size 0 or array 2 is size 0? And then I can go back and look and, okay, yeah, they could be 0. So what happens then? And I would walk through line by line of my solution that I wrote on the board with the case that it's size 0. Or what if the arrays are the exact same? What then? And I try to talk through this, and honestly, now I've covered all my bases in my interview. And that's why I personally like whiteboarding interviews better, is because I get to talk through my solution. Whereas if this was a LeetCode or HackerRank, you have to do all this process on your own, in your own head, and you need to turn in the most optimal solution, right? Because if I turn in a not optimal solution, then like, I don't know, good luck. So that's why you have to be really challenging your own thinking every step of the way. Being like, okay, I think I can solve it this way, but honestly, there has to be a way I can do this faster. So good things to chew on. Thoughts on this?
There's a question in the chat. Do we do edge cases last?
You don't have to. I think it depends on the problem for me. And honestly, when it crosses my mind to think about them, I think usually for me personally, I encounter them in the middle of like when I'm talking through my solution. And if I'm on a whiteboard or if I'm live coding in front of someone, because that'll probably be what happens a lot this recruiting season, is you'll be on a shared screen with someone and they'll be watching you type while you're on a video call with them and talking, is I would maybe make comments at the top of my file, edge cases I'm thinking of as they like pop into my head. Or as I'm coding and I'm like, wait, maybe it wouldn't work for this. I would jot it down up at the top. That way I remember, and it doesn't get me too sidetracked or distracted from getting the skeleton of my algorithm kind of placed there. Cool. If there's no more questions, I have one more problem that's a medium that we can work on. And I would really like if y'all want to like talk and we can kind of work through this thought process together. So take a second to read this and then we can all kind of chime in and work through it together. So we can go ahead and start talking about it. Again, the general gist is we want to find the duplicate numbers. So duplicate numbers, interesting. And we also have these constraints down here we have to keep in mind. We can't modify the array, so that means we can't sort it. We can only use constant space, just O of 1, so we can't allocate a whole nother array and then sort it into that one. And our runtime complexity has to be less than O of n squared. Okay, and there's only one duplicate number, but it could be repeated more than once. Wow, okay. So that's a lot to digest right off the bat, right? So I can kind of get us started in talking through it. Like, damn, okay, duplicate numbers. Well, I can't use a map because I can only use O of 1 extra space. So, because that would be my first idea. If I'm trying to find duplicates, kind of like the one we did earlier, right? Where we were able to increment the number of times we had like collisions. But we can't do that. Dang. And, now what if we wanted to compare each number to all the other numbers? We also kind of talked about that early, that approach. And that would be what runtime?
O of n squared.
Yeah, right, because we're iterating through the array, comparing it to every other element in the array. N squared. Okay. And yeah, n squared could work. That wouldn't use any extra space. It meets this constraint. But I think we can do better. I don't think that's the most optimal way to do it. So we talked through how we want to do that. Yeah, we iterate through the array, comparing every other number to all the other numbers. Okay, maybe it actually is an easy problem. But if we want to optimize it, is it really that easy? Right. So anyone have any ideas on how we can make this faster than n squared and not use any extra space?
Well, one of the things, I mean, the main thing that we might need to understand is, like, if there are two duplicate numbers, or if there is a duplicate number, maybe those two numbers have to be, when they're subtracted, they have to be 0 or less than 0.
That would still be n squared though, right?
Yeah, that would be.
And right, when we use O of 1, can't use a second array. Okay. And honestly, when I sat through this one and worked through it earlier, it took me about an hour. So
I had an idea.
I'm sorry?
I had an idea.
Yeah, what do you think?
I think if you take the sum of all the numbers, like if you iterate through all of it and take the sum, you can compare it to like using the simple sums equation, like n times n plus 1 over 2. So you can compare the sum of the array to what it should be. And then like if you find the difference of those, that should be the one number that's duplicate.
That could work. I'm not sold on it, but it might work. And what would be the time complexity of that, do you think?
Oven.
That's what it sounds like to me. So that could be faster. And we could go kind of down that path on exploring that. But I'm not sure on that one. So does anyone have any other ideas before I surprise y'all with my hour of work from earlier?
If you sorted the arrays using something that was less than O of n squared, and then you had a second part where you iterate through like the entire array, then wouldn't the duplicates, they'd show up like right after each other, right? And
Right.
you would need only one space to store the number before that? I don't know. I don't know like if you can do the sorting in less than O of n squared though.
Right. The fastest sorting algorithms can happen in O of n log n, which is like merge sort or keep sort or something like that. But we look at this note number 1 down here, and we can't modify the array. It's read only, and we can't use any extra space.
Oh, okay, never mind.
So, right, that was my thought too. I'm like, shoot, we just sort it, and then when you encounter like your I and your I minus 1 are the same, then shoot, that's it. But it's not. All right. So
I think, sorry, I think there could be like a solution. Basically, have 2 pointers start at the same, I guess, starting point, and have 1 pointer basically traverse twice as fast as the other one.
right, that's exactly what we're going to do. So is, boom, we use slow and fast pointers, which if you haven't heard of, using this type of cycle detection algorithm, there's honestly no way you could just like come up with this on the fly, or at least I couldn't, because it probably took someone a couple hundred years to drum this one up. So I don't think you can probably just, I'm not gonna, since it's recorded, but anyways, so, but when you think about, if I want to find duplicates and I can't do anything, that's kind of like finding a cycle in a graph. Is I want to find where these 2 numbers are hitting the same thing. So if I'm going through an array with a slow one where it's moving 1 by 1 and this one's moving by 2 every time, when are they going to catch up, right? Thanks. So this is how you do that. And when I'm thinking through this, I'm like, wait, I remember that detecting cycles from my algorithms class or from my reading, that's O of n. And that's definitely a lot better than n squared. But why my solution to this makes, like, anyone can solve it the first way, right? In a coding challenge and submit that. But it's actually not such an easy problem doing it this way. And not that many people are going to remember this algorithm. That's what makes you stand out in interviews and in coding challenges, is being able to pull this out of your toolbox and be like, I remember detecting cycles in a graph, and I think I can apply it to this problem. And boom, you got a really good solution with O of n time complexity. So you can take a look at these slides later, and honestly, I had to draw this out on a sticky note with like 8 different arrays to prove to myself that this was going to work. So I didn't just come up with this and I'm like, yes, perfect, this is what I'm going to do. And like, boom, it works. No, I literally, like, you can see right here, I'm like fast, slow, and I'm like pointing through each of them. This was me earlier. And I was like, I don't think so. And then I looked at discussion boards. I'm like, I guess that is what it is. So no matter how old you get or how experienced you get, some of the stuff is just straight hard. And it takes you a while to learn to recognize these patterns, and that's okay. But like I'm doing right now, talking through my thought process and challenging myself and challenging you guys each step of the way, that is key. And coming up with these time complexities and bringing up time complexity while I'm talking about it. Sometimes that's something I forget to do too, is I'm like talking through a solution. I'm like, oh yeah, this is great. This is going to be faster. But I should mention it's O of n or O of n log n to like further round out my like portfolio of skills that I'm presenting them. It's like, wow, I know a lot about time complexity too. I'm not just kind of like, oh, this is faster. I'm like, I know it's faster because of this. And that is all like further proving that I know this problem and I know my algorithms and I understand time complexity, because that's like invaluable when you're developing for a company. Is you can't just write code. You've got to write beautiful, clean, and fast code. So super key. So that kind of wraps up like what like the problems I wanted to walk through. But please ask me tons of questions. I can talk about all of the stuff. Me, love talking about myself. No, I'm kidding. I am a TA and have been for like 2 years now, and I love doing that. And I love interning, honestly. I think it's super dope, and I'm excited and scared to go full time. But yeah, hit me with it.
So I just have a, so basically right now I'm like at my 4th year and I'm graduating in spring 2022 probably, and I'm looking for a summer internship next year, so next summer. So is it, I guess, am I a little bit, it, I'm taking a lot of pressure in this sense. This is kind of like the first time I'm kind of getting a little bit serious about recruitment, because previously I did not know what my path was. But is it is it too late for me to actually learn this stuff and be serious about it?
No, never too late, dude.
Okay.
It's just important to show that you're trying your best and put honest effort into it.
Okay.
Like, to be straightforward, it's not enough to just go to class and like come home. This is stuff I study and studied all summer. This is stuff I do in the evenings, and it's not enough just to go to class, unfortunately, for our like career paths that we've chosen. You have to be doing this stuff on your own and teaching yourself more than is taught in class, and that will get you those good jobs. So yeah, gotta grind. And cool, Julie, you asked, do you feel in an interview you can't figure out the coding problem? Not necessarily. Some companies, yes, you get like, not thrown in the trash, but like you get rejected if you can't solve the problem. That is more common with like online coding problems that I get like a HackerRank or a LeetCode that I have to do. And if you fail that, then you're probably not going to move on. Which, fun fact, last year I applied to about 130 internships, failed about, I don't know, 50 coding challenges, got ghosted by another like 30 companies, and then the other, like 50, I passed first round, and then ended up with about 5 offers. And that's kind of the numbers game that it is 130 applications. Some people can just apply to Google and get an internship and like, boom, I'm so happy for you. But for most people, that's not the case. And I know that I'm not going to pass every coding challenge, and I don't expect to. So my approach is I have a giant spreadsheet that I keep track of, all the companies I've applied to, my stage that I am in the interviewing with them, the name of the recruiter, and where they're located, all of that in one place. And that helps me feel like it's not just this like, oh my God, huge thing. I don't know how many applications I've sent out. How many coding challenges do I have? It's all in my spreadsheet. So I don't have to lie awake thinking about it. But I definitely have done like in-person technical interviews where I don't get the question right, or I won't finish it, and I move on, or I get the job. Because I talked through my thought process, and I like asked questions or clarifying questions, and showed that I was really invested in the process. I wasn't like, oh, I'm not going to figure this out. And people definitely do that. And if you do that, like, don't, because that is what gets you eliminated, is that kind of attitude. So it's important to be like, okay, I'm going to keep going. You have 3 minutes left and you know you're nowhere close. Keep going. What is there to lose, honestly? Do I feel like a lot of lower level ECE classes are almost useless? I'm a first year. Yeah, LMAO. Because you will not be in an interview, you're not going to use assembly like you do in 306. And I guess in like a lot of the other stuff you learn in 306, like computer architecture is useful when I interviewed for more computer architecture roles. And when I used to interview for embedded systems or hardware roles, I did have to solve a few circuits on a whiteboard. And that was 302 knowledge. I was like, oh my God. And he's like, figure out the current in this branch. I was like, holy mackerel. And I'm just like drawing it out. And that's when Kirchhoff is coming in clutch. So that is like really key to internalize everything, even if it's not like you don't think it's super useful. But yeah, that's why I'm saying like you gotta teach yourself a lot outside of class, especially if you're a first or second year. Yeah, cool. Yeah, 312, love that class. That's why I TA it, is because like it's the class where I was like, wait, I think I can program. And I like finally understood like what programming was, and I like want to do that for other students because it's just like so exciting and empowering. And you're like, wow, I can compile and run a program on my own. So cool. Any other questions? Good stuff, good stuff.
I feel like a lot of people don't really talk about this, but how do us EE kids stand against like computer science kids when it comes to software engineering positions?
Some people are like, oh, I feel disadvantaged. I don't, personally, because I've put in effort outside of my classes. And I honestly attribute it to that. Because I like computer science, I like programming, I think it's pretty cool. But that being said, programming is not my hobby, as it is for like a lot of people. And I'm not ashamed to admit that. I don't do this super for fun. I don't like chill and write programs. I'd rather like watch TV or like run, honestly. But it's important to put inside like that outside work. And I have felt like I understood some things more than the CS kids at like other internships, but there's some things I knew less than them about. I knew less than them about like web development, or like how to utilize a cloud server, or like all this random stuff that we do not learn in class, even when you're a senior. So that stuff, I'm like, oh shoot, I gotta do some Googling, or like some more detailed Python work we haven't done in class. And like, maybe I haven't done on my own either. And I'm like, oh, Googling while my manager is talking, because I'm like, oh God, I don't know what that means, but the CS kids do. But then there's some stuff that I know a lot more about. And yeah, so it's kind of give and take. I don't think it's black or white. We're like, oh my God, we're so disadvantaged. But
okay, thank you.
Yeah, I definitely like knowing more about how computers actually work than CS kids. I take a lot of pride in that. It's like, yes, I can write code, but I also know what's going on in the computer. So sometimes I flex on that in interviews, and they think that's funny.
Speaking of CS courses, why can't we just take the CS courses without like?
Yeah, excellent question, dog. I've been asking that for 4 years.
Yeah.
Yeah, take that up with the department.
You mentioned that you applied to over like 100 companies and all that for one summer, like for one summer internship. And what do you think is like the appropriate amount for like the average EC student to be?
Yeah, honestly, maybe how many I applied to is overkill for some people, but I know like most people I talk to probably apply between like 60 and like 150, because with interning, in my opinion, it's a numbers game. I don't care what company I intern at, I just need a internship. But I'm approaching it differently for full-time, because I'm not going to go work just anywhere. I want to apply somewhere where I'm actually going to go move and live and work there, right? It would waste my time to apply everywhere. So for each person, it's a little bit different, but I felt like I didn't have the room to be picky when I just needed any internship to get the experience. So I would aim like both like me, my friends, people I know, like my sister and her coworkers who are software engineers, is makes sense to about have like a 5% success rate when you're applying for internships. It's a little bit different for full-time, but 5% is about it. So if you want 5 offers, you better apply to around 100 companies.
And then do you recommend going to the CNS fair as well as the engineering expo? Like, because they have a lot of CS positions there.
For sure. There is value in going to the engineering expo, but there are not a lot of tech companies there.
Yeah.
Because those tech companies don't want to come to campus twice. And that is like totally reasonable for them. So I always go to the CNS fair as well. Honestly, Expo, I've never like interviewed with anyone there because I'm not really interested in those companies. But I always did a lot for the CNS fair because that's where all your big tech companies are. So definitely go to that one. And picking questions to do on LeetCode. Super good question. Let's see, let's exit this because I can kind of show you. So yeah, my account, I just go to problems, and some days I sort by acceptance, and this means like the number of problems that people submit, like submit your problem, and the number that actually like return like passed all test cases, because that means that these are probably like problems that a lot of people are able to solve per se. And sometimes I sort by difficulty, and you can also sort by topic, and that's how I found the ones for today's like section. I was like, I think I want to use one with an array, and then I go into the array section, and then I sorted by difficulty, and I went through there. So you can see I haven't solved like all of these. Some of them I have, some I haven't, most I haven't, but I've probably done like half of the problem on a lot of them. And there is value, let me say this like another thing, there's a lot of value in, if you don't know a problem, that's totally fine. It's totally fine to look at the discussions tab. Say I'm like looking at this one and I'm like, oh Lord, I have no idea how to do this at all. I'm not just going to exit the problem out of frustration, because that wasted my time. It wasted my computer's time, for Christ's sake. Like, let's do something with my time to make myself learn it. So I'm like, let's look at the discussion tab and figure out, okay, I usually do it in Java. That's why I feel most comfortable reading it. Cool. Let's look at this. Oh, wow, this person actually worked through it. And I take time, I draw out pictures, I'm reading through every line of code, and I teach myself how to do this problem. That way I don't make this mistake in the future. I know how to solve this problem. And then after I read through it and I kind of internalize what this code does, then I'm going to go back to the description and try and do it without looking at it. And if I get stuck again, then I'll go back to the description and or like the discussion area, and I'll look at it again. And like by the time I finish this problem, I better know it because I spent time investing on this. How much time do I spend on these every day during school? Right now, since I'm like, it's recruiting season, I'm probably doing like 3 or 4 hours during the weekday and maybe like 5 hours on the weekends, maybe less, honestly. I did a lot during the summer, but I know it's like too late to do that for y'all if you didn't do that over the summer, and that's totally fine. But don't get intimidated by, oh my God, there are so many problems. Every problem you teach yourself how to do is one more problem than you knew how to do. It's not about like, oh, I grinded out like 200 LeetCode problems. I'm like, congrats. It's like, did you actually like understand how to do them and be able to do them again? That's the real question. So that's why it's important to really read through each problem and digest it, because recognizing that problem again in an interview is the purpose of doing this, is to expose yourself to as many problems as possible. How much time do I spend on question, title, get solutions? Honestly, a few minutes. If I look at it and I'm like, holy cow, I have no idea where to start, and I'm just kind of staring at it, rather than getting like pissed off, I just like look at the discussion and I read through it, and maybe I only glance at the code in the discussion and I'm like, oh, they use this data structure, and then I go back and then I try and like work through the rest of the problem myself. So don't get like too triggered by the problem if you don't get it. And also make sure to diversify the types of problems you're doing. How I clicked on like array problems, don't just do those because you know them. Make sure you go through tree problems and like maybe teach yourself dynamic programming, or going through like hash set problems, or all of these. It's good to diversify. Cool. Any last questions, or is it time to go back, Mohit?
Yeah, I mean, I think there's nothing going on back there. So
Okay, cool.
if anybody has any questions, they can go ahead. But yeah, otherwise we're just done. So you can move.
Right. Thank you.
Yeah, no problem. I'm super happy to help. So I wish you could say hi to me in the EER.
Thank you.
Yeah. So have you asked how much value do I get from Expo? Some people get a lot and they get like on the spot interviews, but it kind of varies. I think it's definitely really important to go and to learn about companies and to meet recruiters. I definitely have people remember me from year to year, and that's not just something people say. People do remember you. So yeah, definitely do that. So definitely go.
I actually thought that allow me to rephrase the question. So basically, on September